Welcome. In this session, we will master the configuration and management of a Microsoft Entra tenant, specifically focusing on how to configure and manage both built-in and custom Microsoft Entra roles to ensure secure and efficient access control. To begin, we must define what Microsoft Entra RBAC actually is. It is the system used to manage access specifically for Microsoft Entra resources. It is crucial to distinguish this from Azure RBAC. Microsoft Entra roles control access to identity resources such as users, groups, and applications and interact primarily via the Microsoft Graph API. In contrast, Azure roles manage Azure infrastructure resources like virtual machines and storage accounts using Azure Resource Management. While both systems use similar concepts like role definitions and assignments, their permissions are not interchangeable. Understanding this boundary is the first step in configuring your tenant correctly. This diagram visualizes the separation between the two RBAC systems. At the top, we have the concept of access control. On the left branch, we see Microsoft Entra roles. Notice that these roles specifically control identity resources. This includes your users, groups, and applications. This path relies on the Microsoft Graph API. On the right branch, we have Azure roles. These are distinct and control Azure resources, such as VMs and storage. It is vital to remember that Entra role permissions cannot be used in Azure custom roles and vice versa. Now let's look at the types of roles available. Microsoft Entra provides built-in roles which come with fixed sets of permissions that cannot be modified. These are designed to cover most common scenarios. However, when built-in roles don't meet your specific needs, you can create custom roles. Custom roles allow you to select precise permissions from a preset list, granting granular control. Be aware of the licensing requirements, while built-in roles are free. Using custom roles requires a Microsoft Entra ID P1 license for every user with a custom role assignment. The process involves defining the custom role first and then assigning it. Here we compare the two role types. On the top path, we have built-in roles. These are static, having fixed permissions, and importantly, they are free to use. On the bottom path, we see custom roles. These offer customizable permissions, but trigger a P1 license requirement for users assigned to them. The creation flow for custom roles is shown at the end. First, you define permissions from the available list, and then you create the assignment to grant those permissions to a user. Let's explore how to create a custom role. A common use case is delegating the management of app registrations without giving full application administrator rights. You can create these roles via the Admin Center, PowerShell, or the Graph API. When defining the role, you select specific permissions, such as the ability to update credentials or create applications. For example, you might select Microsoft directory/applications/create. To perform this action, you must be signed in with at least the privileged role administrator role. This ensures that only authorized admins can define new privilege sets. This sequence shows the creation process. The privileged role administrator initiates the action by selecting new custom role in the Entra Admin Center. The system requests basic info like the name and description. Next, and most critically, the admin selects specific permissions from the available list, such as app creation permissions. The system validates these, and upon selecting Create, the new custom role is finalized and ready for assignment. Once a role exists, we must assign it. You can assign roles directly to users or, for better scalability, to groups. Using groups to manage role assignments simplifies the process. When you add a user to the group, they automatically inherit the role. However, you cannot just use any group. You must create a new group with the isAssignable to role property set to true, or set Microsoft Entra roles can be assigned to the group to yes during creation. Note that this property is immutable. You cannot change an existing group into a role assignable group. This capability requires a P1 license. This state diagram illustrates the group-based assignment flow. First, you start the create group process. A critical step is set property, where you must set isAssignable to role to true or yes in the portal. Once created, you assign role to this specific group. Then you simply add members to the group. The final state is inherit access, where those members automatically gain the permissions of the assigned role. This creates a scalable governance model. We have discussed what permissions users get. Now let's discuss where they apply. This is called scope. By default, roles apply to the entire tenant. To restrict this, we use administrative units O. O let you subdivide your organization, for example, by department or school. You can assign a role, such as user administrator or help desk administrator, scoped specifically to an administrative unit. This ensures that the administrator can manage users within that unit, but cannot touch users in the rest of the tenant. This diagram demonstrates scoping. The large box represents the tenant. At the top, a global administrator has scope over the entire tenant and all users. Inside the tenant, we have a smaller container, the administrative unit for sales. We assign a scoped user admin here. Notice that this admin only manages the sales users only. They do not have permissions over users outside this blue box, effectively enforcing the principle of least privilege via scoping. To secure privileged roles, we use Privileged Identity Management, or PIM. PIM allows you to grant just-in-time access, meaning users don't have standing access to sensitive roles. When assigning roles in PIM, you can specify the assignment type. Active, which means they always have the role, or eligible, which means they must perform an action to use the role. When an eligible user needs the role, they activate it. This activation can enforce security checks like multi-factor authentication, MFA, business justification, or approval from a designated approver. This significantly reduces the risk of compromised accounts having permanent administrative power. This diagram flows through the PIM lifecycle. We start with an eligible assignment. The user does not have permissions yet. When they need to do a task, they initiate an activation request. This triggers security checks, such as requiring MFA or entering a justification. Upon success, they enter the active state, possessing the role permissions for a limited time. Once the time limit is reached, they transition to expired state and automatically revert back to eligible assignment, removing their standing access. Finally, let's cover critical best practices. First, always enforce the principle of least privilege. Avoid assigning the global administrator role when a more specific role, like user administrator, will suffice. Second, you must create at least 2 emergency access accounts, often called break glass accounts. These should be cloud-only accounts permanently assign the global administrator role to ensure you aren't locked out during an emergency. Third, use cloud-native accounts for all privileged roles to isolate them from on-premises security compromises. Lastly, conduct regular access reviews to remove stale permissions.